So what happens after we run the ANOVA or the omnibus test and our neighbor omnibus, sneaky omnibus, tells us there's something in that bag? So when the F-test turns out to be significant, we know with a certain degree of confidence that there is a real difference in that bag. And now we want to know what that difference is. If there's more than two groups, we can't just guess like we did with the independent T when we said, oh, it's males versus females. Well, I now know which two groups differ. If there's more than two groups, it becomes more muddled and I'm not quite sure where the difference is. So we're going to do something called post-hoc tests. Those have been designed to do all the pair comparisons that we'd like to do, but first you have to do the omnibus test to be able to justify moving on to post-hoc tests. So post-hoc stands for after the fact. So you can only run post-hoc tests if the omnibus test was significant. In other words, you can only run post-hoc tests if your ANOVA is significant. So here's just some simple descriptions of some of the kinds of post-hoc tests that exist. There's actually many more. But if you run if you run an ANOVA and it is significant, then you would ask your computer system to run a post-hoc test. Now, you can run what's called a Tukey, because it was invented by Dr. Tukey, where if you have equal sample sizes among all your groups, then you can run a Tukey, and it's probably the best one to go with. It assumes that you have equal sample sizes across these groups. Let's say you don't have equal sample sizes across your groups, you have a really large difference in sample sizes, then you would run a Chaffee. Now, a Chaffee is not the ideal approach because it's really conservative, which means it's really hard to find significant differences with a Chaffee. However, it is what you would need to do if you don't have equal sample sizes. And I always like to throw in Bonferroni because I feel like Bonferroni is really the concept of what we're doing, except it ends up being even more conservative and probably not as useful. But here's what Bonferroni is doing. If I have three groups and I want to maintain the alpha rate at 5% for all of them, then instead of doing 5 plus 5 plus 5 and getting an alpha rate of 15, do you see how I could take my 5% alpha desired rate and divide it by 3? And that way, when I sum it up, the entire paired comparison group would be an overall alpha rate of 5. That's essentially what Bonferroni is doing. But if you have lots of groups, you would then be making your alpha rate for each pair comparison really, really small and making it really, really hard for you to find something in the rejection region. So in short, post-hoc tests are designed to do all those paired comparisons that we wanted to do when we were doing an independent sample T, but they are designed to maintain our alpha rate at 0.05 better. And we're justified in doing post-hoc tests because we already ran the ANOVA omnibus test that told us there was a difference worth pursuing.